Ladies and gentlemen, we are Monday morning. Monday, I believe it's the last day of April, isn't it? Is today May 1st? Oh my God. Today is May 1st. That means that spring has sprung, the grass is riz. I wonder where the flower is. That's what my mother would always say. Back here we have two questions, both related to 9.2 on graphing and solving linear inequalities. Our first question is fairly simple. It says, x minus 5 has to have a value, this expression, when x is substituted for whatever number we're talking about, that value of that expression has to be at least greater than or equal to 1. So if we solve it, we're going to solve it just like we would algebra. We're going to add 5 to both sides to get rid of our constant. So if any value that is greater than or equal to 6 will work. That is the first part called solving. Once we have that done, we're going to create a set of values that are valid. So in that set of numbers, any number that is greater than or equal to 6, what is the first number that is greater than or equal to 6? We're going to have 6 in there. Now technically, 6.1 or 6.2 or 6.001 or 6.0164 or 389 is totally true. But if we simply keep our numbers whole numbers, 6, 7, 8, dot, 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 that is the mini set of numbers that are valid values of x. X can be any of those numbers, right? And then graph it on the number line. If we put our actual value of 6 in the middle, any number greater than or equal to 6, so what kind of boundary point will I use, open or closed? Closed, because it does include the number 6 as valued here. And any number that's greater than or equal to will be any number that follows on that red line to infinity and beyond. Now, there was one thing I said that you should have probably done, and in hindsight, I'll do it next time. Take one of these values, any one of them, and substitute it into your equation here. So 7 minus 5 is greater than or equal to 1. Is that true? Well, 2 is greater than or equal to 1. Is that true? Yes, it is. So 7 is a value that maintains the inequality. In our second example, we have what number divided by negative 3 has a value less than 1. So the first thing we're going to do is solve it by multiplying both sides by negative 3. Now, here's the trick part. What did we say last day if you multiply or divide by a negative? You have to flip the inequality sign, which means that is going to be my new inequality sign, correct? Remember we said that? Negative 3. If you did not flip the inequality sign, you ended up with an incorrect inequality. So when multiplying or dividing both sides by a negative value in the solving of the inequality, you need to flip your sign. Our mini set of numbers would be any number greater than negative 3. So is negative 3 going to be one of them? No. We're going to start with negative 2, negative 1, 0, dot, 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 positive infinity and beyond. We could substitute one of our numbers in here just to check. I'll use, let's just use negative 1. Doesn't matter which one we use. So substitute that in for the x. Oh, sorry, it's supposed to be greater than, isn't it? Oh, sorry. Sorry, it is the less than sign. Take our original equation. Substitute that in. 1 divided by 3 is going to be a positive 1/3. And is 1/3 less than 1? Yes, it is. So therefore, it's a valid solution. When we graph it, we're going to take our negative 3 in the middle. Negative 4 would be over here. Negative 2 would be here. Open boundary point this time because it does not include the number. And any number greater than negative 3 means that my number line goes that way to infinity.